Hi guys, so some people have asked for some Java basics. So that's what we're going to go through today, just some of the smaller building blocks of Java for people to learn and go back and look at later. We're using Eclipse, which is an IDE. It's like a way to help us program, but you could use any of the Java things that you like. Today our focus is going to be on data types, though I should say, just in advance. So if you're not using Eclipse, you can skip through to the actual starting point of the data types. But for those of you who are using Eclipse, we're going to do File, New, Java Project. And I'm going to call it Java Basics. Okay, and then you get so there's different versions of Java going back and forwards. We're just going to do the standard one that we've got here. This might be a bit old, but it will work for basic stuff is always going to be the same. It's only if you're really dealing with super advanced things. I'm going to click Finish. Okay, now it's asking me to create a module info, so I'm going to create that, and that's just extra info about the project that we can deal with later. Again, you don't need to worry about it. So one thing with Eclipse is it really likes you to put things into packages, and these are just ways to group programs together. So we're going to make a new package as well. New package. Now, if I call it Java Basics, like I did before, you notice I get this exclamation mark, okay? Because there is a convention that our project names should start with a lowercase j. Okay, so it's something to look out for, is try and follow the conventions, because if you're working with other programmers and you're doing it completely differently, they're all going to hate you. Okay, so just follow the rules that people use. Is nice. Okay, so we've got our Java Basic project, and then we get to the real thing, which is our class. Now, a class is just a single Java file for now. We'll worry about object orientation and stuff in A-level, but for now, if we make a new class, and again, it expects it to be an uppercase this time, and this is going to be data types. Now here I want to click on public static void min string args, and click finish. Now clicking that button just basically gives me this line for me. You can type it yourself if you want, but you don't have to. And this is what's called our main method. This is basically the thing that will run first in our project, when we click the little place sign here. It has this // inside it. This is just a comment. So this won't do anything at all. It's just a way for you to share other information with yourself or other programmers as you go along. Boom. Okay, so first of all, data types. So there are different types of data, and the most basic are our primitives. These are like the basic building blocks of all the other data types. So we can have int, number. Okay, so we get an integer. An integer is going to be a whole number, like 9, 7, not 7.2. It has to be a whole number. Okay, now this part we can call our declarations. Okay, so we're declaring number as an integer. All that's going to do is basically take a bit of memory somewhere and say, okay, I'm going to reserve this space for an integer. However, we could also have numbers that do have a floating point, and these are called, in Java, doubles. You'll often see them as floats. We tend to use doubles. It's just different programming languages have different names for the same things. So I could call this one, I don't know, pi. Now, what's the difference? So an integer has to be a whole number, and pi has a point on it, has a decimal point. And this is all just to do with saving the correct amount of space in the computer's memory. So you don't want to waste memory. So for example, if a number does not have a decimal point, then there's absolutely no reason to use a double. So I can make my memory more efficient by using an integer instead. Other primitives we have would be a character. That's just like a single letter. And we could also have a Boolean, which is going to be like a yes, no. So let's say found is often a common one to use. Okay, so these are the declarations of 1, 2, 3, 4 primitive data types. Notice these all start with lowercase. There are other data types though, and these are like general data types. They're less primitive. These tend to be made from the others. So The one you probably use the most, the data type you probably use the most, is a string. And notice starts with a capital S. So this is going to be string line, let's call it. Now, a string is made up of many characters. Okay, so there might be other data types we use, different composite data types we'll come to later that we could put into that. But these are the 5 main ones that we're going to be using as we go through the course. Now, oh no, why are they all yellow? This is just a warning and eclipse to tell me that I've not used it, and so I'm wasting space. Yeah. So, but once I start assigning things to them, that will work. So I can initialize variables. Oops. Init for short. So I could say something like number equals 9. Double equals 3. Oh, not double equals. Sorry. Pi equals 3.14. I can't do all the pi numbers, but I'm sure some of you can. Character equals z. Now notice that this has single quotation marks. That becomes important later. So a character has single quotation marks. Found can either be true or false. Yeah, that's the only options. And then for our string, we could say line equals, now double quotation marks, use the traditional one, hello world. Okay, and these are examples of how you could initialize your data. Now, you don't have to have them separated. You can do number equals 9 up here. When you are declaring it, you can also initialize it. I'm just separating it out into 2 different sections so that you can see that there is a difference, especially in our exam language. When you're asked for declarations, it's talking about this. When you're asked for initializations, it's talking about that. Okay, so for now, it might be better just to separate them and keep them out. So you might be wondering, well, okay, that's great. So, but can I change from one to the other? Yes, you can. Okay, so if I wanted, for example, pi to become equal to the number, I could try that, and that works. Okay, now, but what would happen is 9 would be fine, so 9 would become 9.0. If I was to do number becomes equal to, let me just close that off in case, number becomes equal to pi instead, ooh, it doesn't like it. Okay, and that's because there's more data inside of pi than number can handle. Now you can still change it, so I can put a bracket in front of it and put int in front of here, and it will do what's called casting. It will change it from one data type to another. But when I do this, I'm going to lose some information. So when I change 3.14 into an integer, it's just going to cut off the last part. So we'll only be left with 3. And that can work as well. We can change from strings to numbers. So let's say I had, let's say string equals string code, let's say, equals, notice double quotation marks, 3345. Boom. Now if I wanted to change that to be an integer, int new code, I could do integer dot parse int and put the code into here. And that would let me change it into a integer. If I were to go the other way and I want to change it back to the code, I could say code equals integer dot, oh, I can't spell, integer dot to string and give it the int, so new code. and that would change it back into a string. Now, don't worry if this parsing stuff is getting a bit too weird and confusing. It will make a bit more sense later. The main thing to understand is that different data types are to do with how we save it in the system. If we use the correct data types, we can save things effectively. An integer is a whole number. A double or a float is a decimal point number. A char is a character, and that's a single character denoted by single quotation marks. Boolean is found. In this case, found can either be true or false. No other options are available. And a string has many characters together on a single line. If you can get that, then that's a good place to start. The casting stuff, you can worry about later on. All right, we'll go on to inputs and outputs next.